So good evening to one and all present here. I'm Dr. Ananthi, HOD IT, Department of Information Technology. I welcome all participants for today's webinar on artificial intelligence. And today's guest speaker is Mr. Karthik Raja. He is the Chief Technologist in Strategic Technology Group of Infosys. And also, he mentors a startup business called OurLocal1.com. He has 21 years of experience, varying from building products to advising customer executives on technology transformation. We welcome you.
Can somebody put everybody on mute or something? Because there's
See, participants, please mute yourself.
Welcome you, sir. Karthik, sir. Session is yours.
All right. Thank you very much, and good afternoon to all of you. I'm delighted to be here speaking to you all. We had the session, for your college in the I think EIE department earlier a few weeks ago, and it's sort of a repetition of that session, but I'm going to be condensing this for an hour instead of probably the 2 hours which I had earlier. So what I want to cover today is give you an overview of artificial intelligence. I find it always useful when you know exactly, what the, if you put a big circle around it and put all the things around AI into that circle, so what that circle will look like, right? So that's what I'm trying to cover. I think there's a lot of noise. I find quite challenging to speak. Rina, there's a lot of noise in the line. Is it possible for you?
Yes, sir. I'll mute. Yes, sir. I'll mute them.
Okay, thank you. All right, that sounds better. So what I wanted to do is to hopefully give you a very good overview of what is AI, right? So just give you the start and the end and what's in between, right? But I will not go in depth. This is not session to go in depth, but this is a session for you to know everything that is there in the AI. That's number one, as a technology. Number two, when you deal with artificial intelligence in your daily life or as a employee working for an organization that deals with AI, what are the things that you need to know about, right? What the industry is worried about, where are we applying artificial intelligence, and how do we do and how do we make better AI, right? So that's what I'm aiming to cover today. 1 hour is going to be a short period of time because I have to sprint. Some areas may look a bit dry, and so hold yourself for that, and I'll try and pace it in a way that it is very easier to digest, right? I'm going to share my screen. A little bit of a house rules, though. When I share my presentation, obviously I can't see the Google Meet. That means I won't be able to see if you ask any questions. So I won't be able to see the messages or the videos, So I would request, the organizers to probably take a list of those questions and, ideally discuss probably towards the end of it, right?
Sure, sure, sir.
And I found sometimes in the past, people tend to, sorry. Bear with me for a second. I think I got it. That's my phone going off in the wrong time, but put that out on the mute now, so should be okay. In the past, I've also noticed somebody accidentally present their own screen. So if I get disconnected, just call out, yeah, stop me and ask me to share the screens. So with that, I'll go over a very quick overview of Infosys Strategic Technology Group. Very, very exciting place. If anybody's interested, let me know. I'll leave that for now. So what are we going to cover today? I will give an introduction to AI in the sense, let's take a look at the history. What has happened over the last many decades, and how do you define AI? So what is AI? What is not AI? How do we get our heads correct, right? And secondly, let's go into the ecosystem. Ecosystem is a very important thing to look at it, because this is where you're going to know what constitutes AI, right? So this is basically the index of a book, essentially, right? If you buy a new book and you want to know what's inside that book, you read an index. So I want to take a look at the ecosystems. Therefore, you will know what AI constitutes and what are the areas to explore. And then I want to just go a little bit into the machine learning and deep learning. These are the two major areas of development. And so let's take a look at that as a context. And then the second set of three titles are more from the enterprise point of view, because today the session is not an academic view of how AI is advancing, but more from the enterprise point of view, how you will deal with AI, right? So what are the things that you would do and so on. So I'm going to be covering from that point. Okay, a brief history of AI. Many would argue that, look, AI is a very relatively new thing in the market. It will take many years, or it may not even fly, and so on. But AI is a very old technology. It's as old as probably 70 years or so now. The first definition of AI probably came in 1942, or the thinking towards artificial intelligence came in 1942. Asimov's three laws, and 1950 Alan Turing's opinions on what is a thinking machine is. So that being the beginning, the golden age of AI is considered not now. It was 1956-73. 1956 Dartmouth project is I think is a summer project where all specialists from all over the world, they got together in a mathematics department in Dartmouth University, I guess, and they spent 6 weeks debating about what they need to do about AI. And off the back of it, several research interest and topics came out, and several products came up. So the golden age is really 50 years ago, or 70, 60 years ago. And then our time, we are probably familiar with what happened with IBM Deep Blue. A chess-playing computer defeated chess champions and so on. How did that go about? We have also studied algorithms in our universities. If you're a computer science student, the graph algorithms and graph navigations and so on. How it detects input into a response. So that we, I think, even expert systems and AI, robotics, and all that is part of our curriculum. We have learned that. And the recent era, if I say that, when you have the artificial intelligence program sitting in your mobile phones for doing several things, right? So you have like Siri, you can talk to Siri, you can talk to Amazon Echo or Alexa, you can talk to Google Home, and there are several devices now. It will respond to your speeches. And some of the companies in the UK, at least, I don't know, in other parts of the world, if you call a call center, the person answers the phone is not a human, it's a machine, right? And then if it cannot handle, then it passes to a human person to deal with that. So that's the current era, and future is there. I have one slide to talk slightly about what the future might look like. But the takeaway here is, look, this old technology is hugely matured, and we are at a stage where this is being used for enterprise adoption, right? And a quick go-through over what happened in 1942. Obviously, Asimov's three laws of robotics. I quite like these three laws because it was so futuristic. For 1942, when there was barely any machines, you know, and if you look at Charles Babbage's computer, it seems like a you know, big machinery that you wouldn't want to even go nearby. But at that point in time, they anticipated that the robot must one day be able to be intelligent. And that's a very important distinction, because you know, until that point in time, nobody thought machines could think. And someone says, look, machine could be made to think. Shall we try and make that machine think? And that vision inspired many scientists to think differently about machines, and initiated many work on putting intelligence into the machine. So that's a, you know, so a lot of undertaking has taken place at that point in time. Another important thing to point out here is there were a lot of debates back in those days about whether machines can think, right? People got stuck in a question, can machines think? And they said, no, it can't think because it's not, simply because it's not a human, simply because, you know, it doesn't have any values, simply because, you know, it's too difficult to make it think, you know, several, you know, arguments about that. But Alan Turing, you know, simplified that. I think that made it very useful for many people to pursue with a lot more stronger belief that, you know, we can make the machines do, you know, make machines more intelligent. He said, instead of asking can machines think and end up arguing on, you know, on that question forever, can we say if machines can do what humans can do, we should assume that it can think like human? You know, I think that's a, you know, a very powerful way to look at it. Just make the machines do what we can do and assume then it can think. I'm not going to go into the various you know, stages of the history of evolution. So that probably for you to maybe go through that later. But when we talk about AI, so what is AI? You know, what is artificial intelligence? You know, what are the things that, you know, we want AI to do, and, you know, to call that as intelligence? So it's these four things. One, thinking humanly, right? So think like human in simple terms. Ability of the machine to think, solve problems, make decisions like humans, right? So it means that there's an application of intelligence there. You know, we take decision by heuristics that we deduced, you know, by experience, by learning, by analyzing whatever that is, and then we want the machines to do the same. And thinking rationally, right? This is another major aspect of it, because see, we, just because we have an answer, not necessarily mean that we take that action with that answer, right? So, for example, you have a tree in your garden, and you know, someone says that you have to cut it. You know, maybe you know, maybe the father says go cut it, but the son may say, look, you know, no, I don't want to cut my tree. You know, I like the tree, or it helps the environment. The children always, you know, have that point of views, right? So what is it? So, you know, rationality is about the value that you hold, the beliefs that you carry, right? So I don't want to cut my tree because, you know, maybe because it's a living thing. You know, I don't want to cut a tree because it's contributing to the environment. I am okay to accept its, you know, disturbances, and yet I want it to be there. But that's not a logical deduction. Logical deduction is if your garden is, you know, cluttered with rubbishes, you go basically cut the tree, right? So thinking rationally, you know, how do we make machines think rationally? And then same applies, you know, thinking humanly, act humanly. Thinking rationally, act humanly. You know, you're able to decide, and you're able to act on it. So that is the definition of AI. It's a quite powerful one, very simple, but yet very powerful. Right. So I wanted to talk about ecosystem. The reason I wanted to talk about ecosystem is so that you get the picture of what is there in the AI. You know, when we talk about AI, you know, I want you to go back after this slide that you kind of know that the several things that constitute AI, right? And you will be able to relate, obviously, except for more advanced algorithms and so on, broadly what this technology do, right? So that's what the ecosystem is meant to. So if you look in the picture on the left-hand side, it's an Oxford University, so I have to call that you know, source. But at the very core of it, you have machine learning, and on top of it, you have deep learning. And then you see on the edges the three different approaches to either of it. The first thing to understand is machine learning and deep learning both are part of our AI. So AI is the larger, holding, name for the things that it does. Machine learning is more of a statistical reduction. It's based on pattern recognition, rules, statistics. If a data says something, you work out based on your analysis. You can come out with a given answer. So what it means is that, let's say, last year, everybody, liked to, or the consumption of sweets, was X, that was, last year. The previous year, it was X minus 10%, and the previous year, X minus 20%. So obviously, in this case, you could probably say, look, the future is going to be X plus maybe 12%, 10% based on historical, and 2% based on whatever, incremental logic it could be, things like that, right? So what I'm saying is, it is hugely based on statistics, usually based on reducing to a particular decision based on the historical data. As against deep learning. Deep learning is also similar. It's not too different, but it uses a different algorithm to do the same. It uses a algorithm based on neural networks, and that simulates the functioning of human brain, and then you use that for processing your solutions. So that's the major differences between these two. And then you have the different algorithms. You could have a supervised learning, unsupervised learning, reinforcement learning, and so on. We'll come to that. So again, recap: machine learning, deep learning. I'm just going into machine learning a little bit more for us to take a look at what that, survey that area and say what is out there. So machine learning is the study of algorithms that are programmed to learn from data or maximize performance based on past experience. Right? Past experience comes from data again. So in order to perform a task more efficiently without explicit instruction. Important thing to note here is based on data, based on past experience. Without these two, you can't, create ML. And the way I like to look at it also, so some of these definitions are very thin, right? So ML is a technique how we implemented AI in the past, and deep learning is a technique that we are implementing AI going forward, right, in the last decade and so on. So it's more of a time-based view rather than a clear differentiation, in my mind. So when you're implementing a machine learning solution, what are the things that you would normally be worried about, right? So one is, you need to choose the right algorithm depending on your solution. If you want to predict a house price, there's an algorithm. If you want to determine whether, the presented question is yes or no, answer for a presented question is yes or no, you will have a different algorithm. And if it is about grouping, you have a different algorithm, and so on. So you choose the algorithm. And AI is all about design patterns, or AI is all about patterns in the data, right? Or pattern in the information. So that is what we are trying to identify, and that is how humans also, learns and decides, right, by looking at design patterns. For example, if you point to a child, point a bird to a child and say, "Look, that's a bird." The child may say, "Yeah, it's a bird." And then secondly, when she looks at another bird, she may say, "It's a bird," right? And she learns very quickly. And just by observing how, the attributes of that bird, right? But next time, if she sees maybe a drone, a drone, or maybe an aeroplane, she may call that as a bird because, the pattern registered in her mind is maybe something that flies, something that is on the sky, and so on. Then you say, "Look, no, that's not a thing. That's an aeroplane." And then, she lands it. So how does it do? How does a human mind learn? He learns by looking at patterns. So what is the difference between a bird and an aeroplane for a child? For us, we know. For a child, both have wings, and one maybe on the ground has a feather, another one doesn't have that, too high up on the sky. That's how it works out, right? And the same thing for us. If we are exposed to something completely unknown, we would also be struggling. If we have to differentiate the 2 letters in Chinese, we would be going with the patterns. We would say, oh, look, there's a little curve here and there's a no curve there. That's how we look at it, right? So it's all about patterns. Data and computing is another major element to your ML. You need a huge amount of data, unlike humans, which can work out much more efficiently with a smaller set of data. I think machines will need a huge set of data to deduce the answers, and requires a computing power. Huge amount of computing power is required. Sometimes when we run this ML algorithms, takes hours and days and so on, and that's not how the enterprise applications have evolved over the last 2 decades and so. Quality and quantity, so both are important when it comes to AI. You need to say exactly what it is dealing with. If you give the picture of a dog and call that as a cat, obviously the quality problem, AI will not be able to figure that out. And the quantity, you need to be able to show hundreds and hundreds of dog's picture for it to be able to know. But that's amazing thing about human, right? So if you see a particular variety of a kind of a dog, and the next time you see something that looks slightly different, you still know that it's a dog. You don't need a picture. You don't need someone to tell you that it is a dog. You know it. But AI would need much more data to be able to process that. Now, yeah, we looked at what do you require. Now, let's say you decided to build a solution. What do you need? You need to be preparing the data. So let's imagine in your university context, you want to create an AI, algorithm for teaching, improving your teaching. What other things you would do? You would start preparing the data that it requires to learn it, and then you build a model. What is the model that you want to, create? And then you have to test the model against the sample outputs, and then eventually deploy. If the model works, fine. If if the model didn't work, you take it back to the workbench and then fix it again and so on. So that's sort of how you do that. Okay, so now we come into the different algorithms in ML as well as deep learning, right? Supervised learning refers to a situation where a task will result in an output. A task has an input and it results in an output, and the algorithm learns to map the input to the output.
Sir, excuse me, sir.
Yeah.
Hello. Good evening, sir. Sir, the PPT is not visible in the.
Okay, I'll just try and share again.
Sir, PPT is visible, sir.
Sir,
In the participant list.
sir, PPT is not visible.
So is it visible for somebody and not visible for someone then?
Sir, it is not visible.
So PPT not
Sir,
visible.
Sir, go to the participant list. There you can see Karthik Raja Gopalakrishnan. Pin it, sir, for presentation. Others, please mute it.
All right, can you see me now?
Yeah, sir, it is visible only.
Right.
Yes, sir, now it is visible.
You can proceed, sir.
All of you to go
Sir,
on
now
mute.
visible, sir.
You can
Alright,
proceed.
Thank you very much, sir.
It is visible, sir. Thank you, sir.
And if everyone can go on mute, that'll be better. Okay, that sounds better, right? Supervised learning, a point is, you've got an input and you want to map it to an output, and based on examples. This is a very important thing. You need examples. You need to tell AI, look, here is a dog, here is a cat, and then you teach. Yes, these are the things that looks like cat, and then eventually, when it predicts, you may be even able to say, look, this is not correct, and so on. So that's supervised learning for you. The two categories of that: one regression, another one is classification. Regression is a predictive modeling technique in that is a task of approximating a mapping function. We said that earlier, right? So what it does is you map an input to an output, right? So you got a photo of a dog, and then you map it to a dog. That's called mapping, right? So from input variables to a continuous output variable. So this is one thing. The other one is classification is more discrete. One is continuous, another one is discrete. What it means, discrete is definitive, right? So it's cat or dog or tree or human or tree or animals, that sort of thing. It's a very definitive thing. So if you want to classify that, you call that as a classification algorithm. Or if it is a continuous output, that means like house price prediction. If you say I have a 5-bedroom house and it predicts the price to be X. If you say it's a 4-bedroom house, it predicts the price to be X minus maybe 100K or something like that, right? So there's a continuous variable that you're driving, and you use different algorithms for that. Unsupervised learning is when you don't tell what you want from that. You don't tell this is a cat or a dog or anything. You just, let's say, imagine you fed AI with all the cats and dogs, and it automatically groups them as cats and dogs without telling you, without knowing anything about cats and dogs. It wouldn't tell you, look, I found a cat and I found a dog. All it tells you is that I found two distinct group of things, right? And so that's unsupervised learning. Clustering is one of the algorithm in it. So you feed the data, and then it just kind of clusters them all together. And this is very useful in several areas. Like, for example, let's say medicine, right? You have a MRI report, and it would be useful if it simply says, groups them together as this is normal and this is not normal, or this is, it don't have to even say it's normal, not normal. It's one category, which is all the pictures of normal one. Another category, all the pictures of not a normal one, right? And it is very important, why this is very important is because you don't need to say how to group it. It automatically groups. So it helps you to find newer information from what you already have. You probably didn't know that before, right? And that way it's very useful, especially for marketing, research, and social media network, behavior analysis, election campaign, targeting and all that places. Clusterings are quite powerful. Reinforcement learning, I'll take that through with an example. So here you don't, again, say what do you want. You don't say what do you want. Like, remember in supervised learning, we say what we want. We say, look, I want you to predict is a cat or a dog. But here you don't say what you want. But what you do is you reward for the outcome. If you like the reward, if you like the outcome, you reward it. If you don't like the outcome, you don't reward it. That's all you do. For example, this girl is teaching a dog, training a dog, and she's throwing a stick. So the dog goes and picks that stick up. It doesn't know what to do with that stick because nobody told that it has to bring it back to that person. So let's imagine, the dog goes and drops that in the dustbin, okay? And then he's very happy because he performed that action. And then if the lady liked that, she was very happy that, oh yeah, this is good. The dog picked up the stick and dropped it in the bin, and therefore I give a reward, I give a biscuit. And the next time you throw the stick, the dog will just go drop it in the bin, right? It'll not probably bring it back to you. But if it breaks the stick and you didn't give the biscuit, it'll learn that it'll not, it should not be breaking the stick. So that's the reward. You don't specify what it should do. You allow it to do whatever it wants. You just, are concerned about the outcome, whether that outcome is interesting to you or not. That's reinforcement learning. Okay. Now, so we looked at the MI part of things, and algorithm sits in both places. What we saw, supervised and supervised, all that, apply in both contexts as well. There are a few things unique about neural networks, so we'll take a look at that. Neural network in AI is referred as well as look at the artificial neural networks. ANN refers to deep learning, or you call that neural nets, or deep learning. There are several different terms probably used, but in short, the idea here is it uses human brain as an inspiration to function, right? So what it means is, internally, how you arrive at an answer, right, is based on how human neural network works. I think in the past 20 years, ago, when we did the university projects in expert systems, we used to, use huge amount of database and then take an input and then break it down into smaller parts and distribute into a graph network, data structure network, and then we try to reprocess them, right? And probably the chess games, you already have examples of that. But this algorithm is different. It works based on the layers and layers of processing. That's where the differences are, and it's hugely interesting because the accuracy is very high, and you are able to give feedback, and it's quite fast, right? So the self-driving cars and so on, it uses this sort of an algorithm, takes the view of the frames, process them very quickly, and then it's continuously processing for self-driving and so on. That video won't play, so I will skip that video one, because you can see the screen moving, but you won't be able to hear the voice, so I'll skip that for a moment. So let me try and explain how this example of deep learning probably would work. Let's imagine that you want to find out from an image whether that image represents a circle, square, or triangle. Now, that's what you want to find out. So you give let's say a circle, okay, or maybe let's say a triangle, right? And you expect the AI to predict it as a triangle across the different shapes. So what you would do is, the first thing is you take that image, break it into pixels, and then feed that into the input layer. So each input, dots that you see will do some basic things. Probably what it can do at the very basic level is just whether that pixel is lighted up or not, right? Because if there is a shape on it, then it would imagine it's a black background and a white pencil to draw that. If the presence of white indicates there's something there, so it'll fire, right? Like the human neuron fires, that layer fires. And then it comes to the next one. Next layer will try and deduce a little bit even more. It'll look at it and then say, look at a couple of them and say, look, what we are saying here is an angle. Maybe this is a 60-degree angle that I'm seeing here, and maybe a slanted line. So the second layer will try and identify a pattern that is a little bit more coarse, right? And then the third layer may be able to say, look, I'm seeing even a larger one, right? Maybe with the lines and three angular brackets or something like that. And then the fourth layer, it will be able to deduce to a particular shape. But what we are seeing here is just like the human learning process, right? So you look at a bird, then you decompose that bird into before saying it is a bird, you know that it has got wings, it has got a beak, it can fly, it has feathers, and so on. So that is the that is this layer, maybe, right? So when it comes to this layer, how do you determine it is a wing? Maybe based on the shape and so on, right? So if you look at from the reverse side, and at the very end of it, an image, is a pixel. At the far end of it, it's a identification of something. So the process of going from left to right is called forward propagation. And if at the result of a forward propagation, the output is incorrect, and then you give a feedback, and it's called back propagation, right? So these are major techniques that you will need to know. Obviously, not advanced techniques, but some of the common terminologies that you would need to know in the deep learning. Right? Forward propagation is the way a neural network produces an output based on the input it's given. It's basically carrying from left to right. Backpropagation is a function by adjusting and correcting the weights. Okay, so I've not talked about weights and biases. What it means is that again, it's an algorithm. So if you want to if you want a particular node to process an information and say, yes, there's something interesting here, it's called firing, right? So it is determined by the weights and the bias. These are numbers internally created and adjusted. It's based on the algorithms. And to start with, you have certain weights, default weight given, and the bias allows you to determine whether it's firing or not. And then as the AI learns, it tries to adjust its number on its own, and then you have a learned model with all created weights and biases that helps you to make a decision. So the backward propagation is a correction of it. You've got the default numbers, and that results in, let's say you give a triangle, and with the base weights and bias, it says, look, this is a circle, and says it's not a circle, and goes adjust the number, and comes back and say this is a triangle, and so on, and it keeps giving some feedback. Eventually it figures out what is the right numbers, weights and biases that it should have to be able to predict that object to the accurate one. I don't want to go much more than that actually today. Whenever I'm aiming to cover sort of the breadth of AI, so I'll park that ideas there in terms of its algorithms and the in terms of the categories and the algorithms behind it. So now we're moving to the next one. Right. That's maybe a bit of a noise here, but bear with me. So we looked at algorithms so far. So now let's take a look at the application side of AI. So now you've got all these advanced things, but where are we going to apply that? Which are the areas that we would apply most commonly, right? Before going there, we need to look at the question: what is intelligent? Because AI is supposed to be intelligent. So what is intelligent? What are the things it can do? Is it just going to be like the most cleverest IQ? You give an IQ test and it is passed with the highest number. Is it what we want, or what can it do? Right? And here's something very enlightening that I want to share, which is historically intelligence was considered a single ability. If you call someone, oh, he's a very intelligent guy, oh, he's not very intelligent guy, right? IQ test was the basis for that, and IQ tests were only analyzing someone's ability, linguistic, logical, and spatial ability. So if you train yourself on these three, by reading several books, you would pass the IQ test and you would probably get the score. But that doesn't explain, right? So why somebody is smart in different things. Someone is amazingly good in handling people. Somebody is extremely good in music and arts, and their appreciation of arts, the way they are able to communicate a very complex message to a very simple picture, it's mind-boggling, right? And the movie dialogues, we are a fan of some of these movie dialogues, right? So how people are able to, to come out with these poems, some of the poets we admire, in our language, how are they able to do something extraordinary, right? So Howard Gardner argues that intelligence is not made up of a single entity. It consists of different abilities, and they are equally important, right? So instead of saying there is a intelligence, he says there are different types of intelligence. Equally they are all the same. So someone who is extremely good in music is as intelligent, or equally, you can say intelligent as someone who is very good in maths. Just that they are different, types of intelligence. So someone very good in, let's say sports, kinesthetic, music, arts, and so on, that forms under a different set, and logical and mathematical, so another type of intelligence. Interpersonal, so we always say the politicians are dumb, but they are quite interpersonal people. They are able to inspire, they are able to, communicate with people, convince people, and so on. So, they are a very intelligent people. intrapersonal, someone who understands themselves. Maybe the saints, the gurus. We say, look, they are useless people, and some, in an intellectual sense, but they are extraordinary on their own. So the point I'm saying is, many times we may underestimate people who are not familiar with certain areas of expertise, underestimate who they are. But this is in a way opening up our mind to see, look, there are many kinds of intelligence, and each of those type of intelligence can be automated, right? So the most common thing that gets automated, and which is fascinating because that is where we spend most of our time historically, is mathematics, right? We spend so many, for the last, as far as I know, as I grew up, for many decades, maths was my, prime focus. Maths was my, interest and so on. But maths is one field where things will get probably automated much faster than anything else. Quantification, calculations, it's already there. We have formulas already there. What human cannot do, machines would do, but it'll be even more, sophisticated as we go. We have musical composers also. There's an AI composer who can now create a unique music. You don't have to say anything. It just creates music on its own. It's a recognized one. It's I think certified recognized musical composer, which is not a human today. Bodily kinesthetic, AI can replace that. You can see robots. They are able to exactly behave like human as they walk and perform activities. And then linguistic, obviously, you saw things like Siri, Alexa, Google Home. They are able to express, through linguistic. What you say, it understands, it responds to you with far more sensitivity, right? And so on, right? So the takeaway from here is several different types of intelligence. Some type of intelligence are, already a target for AI. Some areas where AI couldn't do very well yet is largely intrapersonal, interpersonal. What it means is that, let's say, a doctor is looking at a X-ray, and he finds out what's happening. Oh yes, this is a COVID-19 virus has affected your lungs. He can say that. AI can do that far more efficiently. If you imagine centralizing AI to do that job, it would have processed millions of such films, and it can, pinpoint with far more accuracy. But it cannot talk to the patient. Patient is not waiting there for a fact. Patient is waiting there to know what it means to him. So you are less interested about the fact there. So the AI cannot probably communicate what it means to that person. If it means that person is going to be, his lungs are half functional, the emotions of handling that is something a doctor will handle far better. So that is where our strength is. Soft skills is where the future for human being is going to be, I guess. Right. Again, now just a quick recap. So we looked at AI, we looked at the ecosystem, we looked at the definition, we looked at the algorithms. Those are the hard things, right? So now we're slowly moving into what it means to employ AI in our day-to-day work, right? So we looked at different type of intelligence that could be automated. And now we're going to take a look at, what it means for us to work with AI, right? AI will increasingly take on labor that is routine and repetitive. If it is repetitive, if you are doing something that every day just repeating the same thing, and you feel that it is quite boring, and very likely that's a work that you could automate, right, with using AI. Automation has always been there. Automation is different to artificial intelligence. Automation, the way you look at it, you could say, your washing machine is an automation, right? It automates a human activity for washing. It doesn't apply much intelligence behavior. It takes away your human effort from you. But if you are able to apply intelligence to that automation, it becomes far more powerful, and that's what we're talking about when we say AI will take over, like self-driving, right? Self-driving is an automation, but it is an intelligent automation. Some sectors will be hugely affected, obviously, but some sectors I think will be more of an augmentation for human, especially like the medicine we talked about. The doctors will still need to be there because his job is to be human connect. Many of our future jobs may be to do with human. If a teacher, a job may be in the future to understand the student more than teaching him, the techniques. Right, because you could use the AI to teach the technique, but the AI cannot understand a student's need. That may be the power of it. So that's sort of a shift we may start to see. Jobs at risk. Okay, why are we looking at this slide? This is to see, look, how, what are the areas being targeted, and what is the sort of areas in which, so for example, food preparation, kitchen, can be automated. And I'm eagerly waiting for maybe a cooker where I can just, say what the recipe I want, and then automatically cooks and serves for me, right? And similarly, so many areas, house cleaning or cleaning in general, sending something into the pipe. They do that today also. If you want to clear something up in the pipes and something like that, you send your robot to do that. Where human cannot enter, maybe nuclear, related reactors and so on. Probably you have a lot of automation already there. Self-driving, we all know self-driving is there. Agriculture in developed nations is one of the pretty difficult thing because the labor cost is so high. If I want to have a strawberry farm, then I have to sell my strawberry for 10 pounds or 1,000 rupees. That's not viable unless I need a machine. I have a machine to do that work. So there are areas where we are forced to do it. And well, teaching is there as well. So at the very bottom of it, obviously, there's teaching. So there are AI impact to our life in information technologies is in the middle somewhere. So what do you the takeaway here is see, a huge amount of work that we do will transform. We don't know yet how much of that transformation is going to be, but there will be a transformation. Either there's going to be an augmentation, or we will be doing a completely different function as against what we are doing today. Areas that will benefit from AI. So where are the areas? Yes, there are jobs at risk, but which are the areas we will improve our life? Medicine definitely, I think, will have a huge benefit by having AI out there. If the machine can detect diseases far more accurately, why not, right? Travel, transportation, logistics, they're saying, AI is already doing a great job there. This is down to, I think, if Amazon says that, they can deliver a package to you within 1 day or certain hours, that's a hugely complex processing that they have to sort out. And in terms of where they will pick and how far they have to drive, what is the driving distance, and whether the weather is supportive of that driving on that particular day, all that calculation they have to do. So they do that. Retail businesses employ AI, automotive assembly, high tech, oil, gas, and chemicals, and there are many areas where this is very interesting for everyone. Banking, obviously, you see. So yes. When you deal with AI, what are we staring at, right? So we're looking at, we looked at several different types of intelligence. They all could be automated, and extending from there, then relating to our daily life. What are the different jobs that AI may be able to perform better, and so on. So we looked at that. So we'll park that for the moment now. And now let's take a look at this is if we use what we have today, this is what we do. So if we evolve AI, even more, advanced AI, what are we going to deal with, right? So one is obviously the connected AI. So we looked at RPA, that's historical. RPA stands for robotic process automation. It uses machines to do machines to mimic human activities. And then we had predictive analytics, advanced data processing engines that learn from data to make predictions based on statistics. This is ML, that we've been using for the last 20 years. And then you have the deep learning, which is the hot buzzword right now, with all the smartphones probably already doing it. You have self-learning cars and image recognition, voice recognition, and so on. And there may be a lot more coming from that direction there, right? Deep learning. The last one is connected AI, right? and probably more in the future. You see those white trees there. We don't know what they are, but there will be bigger and bigger applications of them in the future. Integration of many deep learning systems. We don't do that today, right? So we only spoke about, if I can teach a machine to find if it's a dog or a cat, but we never, put together 5 of those, sort of a deep learning algorithms to do something even greater. So imagine a fire broke out in a house, and one of the robot is specialized in how to put off the fire. Another one can probably rescue people. Another one can maybe lift and lift heavy objects and break the barriers and so on. And if you put them all together, it forms a team to go and extinguish fire, right? So, and SWAM technology we talked about. I think we may have seen some of the science fiction movies where hundreds and hundreds of mini drones flying all around the place working as a team. And then they talk to each other, they signal each other, they work as a team. That's sort of a connected AI future probably we'll start to see. Okay. Some of the research areas, particularly around the hardware, right? So in order to support these modern algorithms, you would need a huge advancement in the ability to process also. So we've been using CPU for a long time. GPU is relatively new, introduced by the gaming industry, but has become quite handy to do data processing. So GPU has become common in data processing systems. But there are more than 100 companies all over the world building application-specific circuits, integration circuits, right? ICs. And there are more than 100 companies. They are all working towards improving the ability to process, data. So, like Google has TPU, Tensor Processing Unit. It's mainly for its AI-related learning exercises, and other organizations are also working in that direction. And there's another one, a startup company called GraphCore. They're working on Intelligent Processing Unit, IPUs. I guess the point is, there's a lot of work going on. From CPU to GPU to TPU, IPU. We will have many different processing units in the hardware area as well. So if your interest is the hardware, there's a huge opportunity to look at how the newer set of hardwares, what sort of newer hardwares are built to process this deep learning more efficiently. And I think it's a huge gap between how efficient a human is in processing information versus how efficient a machine is at the moment. Human, it's an amazing machine, right? So we're so intelligent, extremely intelligent. We need very, very less power to do that. By consuming what's out in the earth, and we live and we apply our intelligence, and it's a low maintenance. Human are a low maintenance superior machines if you really think in terms of evolutionary curve. But machines are not there yet, so there's a huge opportunity and a huge gap to fill. A quick snapshot of all the companies that are, not all the companies, probably many of the companies working. Point here is, see, AI is already a very crowded place. So if AI, if you're not familiar with AI, better be ready to go in and research it and learn it as an important field of study, because it's already a very crowded area in all different areas: healthcare, retail, government, media, transportation, education, everywhere. AI is already starting to contribute. It's a very crowded place. Right. So now we kind of touched on enterprise context, right? But one of the very, very important question for applying AI in the enterprise context is the ethics, right? So how do you, for example, if you imagine that your boss is an artificial intelligence system, right? So how do you feel about that? If a doctor is an AI, doesn't talk to you in a nicer, sensitive way, or even if an AI talks to you in a nice way, will you trust that AI, right? So how do you allocate wealth generated by AI? So if AI is doing all the work, and it means that humans cannot do the work. Imagine a worst-case scenario. Maybe all the taxis are automated with self-driving cars, and there are 130 million taxi drivers who is not losing their job. So, what should happen? Because the quantum of how much AI can do is much higher. So it can suddenly, with the few advanced technologies, suddenly in 5-10 years you can make 100-200 million people redundant. So how do you distribute wealth generated by AI? If government takes taxes, how do they then generate wealth? And what happens to the human workforce after AI is taken over? So what are the things to deal with? If a taxi driver doesn't have a job and he doesn't know anything else to do, what do you want to do with him? How do you help him be a very happy human? So that's an important question for us to answer. We can't simply just take out people from the economy and then do nothing for them, right? So how do machines affect our interactions and behavior? There's a question. If your boss is an AI, how do you talk to that AI? Will you talk as open as you would do to your other boss or a friend? How do we remove bias and mistakes? I've got a couple of slides to cover that. We'll go in there. How do we check an unintended consequences when using AI? If AI, let's say you have a self-driving car, it just went and hit a person. You didn't do anything. It just went and hit a person. So what will you do next, right? Will you drive the same car again, hoping that it will not do that mistake? Or will you be very anxious? And if a person, imagine the car met with an accident, and next time somebody crossing the road, you will be very shocked what the car, worrying about what the car is going to do. Is it going to hit or not hit? Is it stop? You will never stress. So in a way, when that trust breaks, I think you will need to abandon that car probably, right? So how do we check in the unintended consequences? How do we correct them? How do we keep AI safe from antagonists, right? So if someone maliciously wanting to cause damages, how do we keep AI safe from them, and so on? There's several interesting questions. I'm conscious of time. I'll anyway move over. Ethics in AI falls into three major categories, right? There are three pitfalls we need to be very conscious about. So one is privacy. AI uses data. AI uses a huge amount of personal data, and it figures out a lot of things about yourself even without you telling them. So, for example, Facebook knows who you are, what is your gender, how old are you, whether you have children, how old are your children, what is your family size, what are your interests, everything it knows. But you did not explicitly say any of this to Facebook, but it knows it. It gives me that data when if I'm a business and I want to market my product to people, it gives me that data. It gives me, I can go to Facebook and say, look, I want to, show my product to all women who has, 5-year-old children or children with less than 5-year-old. It allows me to do that. So it collects that much data about you, right? And that's a privacy violation because you think what the system, system knows a lot more about who you are, right? So what is allowed, what is not allowed. Second is replication. Right, like when we looked at the deep learning, we talked about the layers and layers of processing, where the weights and bias gets automatically adjusts. And we have no control over what is getting created there. What is the processing logic that results in an answer that's acceptable to us. In a case of dogs and cats, it's okay, but if it's a self-driving car and it made a mistake, and you could not find out why that mistake ever occurred because you have no visibility into the AI brain, just like human, no one knows how we will behave, right? There are dangerous humans, can you go into their mind and read their mind? You cannot read their mind. The same thing with the machines as well. If it makes a mistake, if it does something wrong, you have no idea why it did that, and the only probable option is to shut down that, right? At the moment. So that's not a good enough thing. For a business like an enterprise, you spend 2 years researching on a particular solution, and then you have to shut it down. So it's not really a good investment for anybody to start with, right? So how do we make it replicate its behavior, and how do we introspect, how do we audit and so on. There are many questions that we need to resolve. The last thing about the bias. So bias, everyone has a bias. What is bias? Bias refers to the decision of either supporting or not supporting a person based on personal opinion and judgment, right? So when we deal with somebody, right, they look like you, or they same racial or gender based bias, or language based bias, or region based bias. There are several different biases humans carry, but we don't want machine to carry the same bias. We want the machine to be independent of these biases, right? Agnostic to biases. So how do we make that? So human is fully biased, and there's a very, very careful thing for us to eliminate that bias. And it's a very difficult job because what creates a bias is not very known. So you can remove, let's say, gender, race, and age from the data processing. But still, without even this information, the AI may know what's your age, what's your gender, and what your attributes are. So and then it can still be very biased, right? So how do we eliminate that? That's a big question to answer. Some examples. I think this is a story about, I guess, Facebook's recruitment system. They created an AI-based recruitment system which can process the candidates to say whether they are suitable or not. And what it resulted in, it seems that it only selected men, and it only selected the white men in the U.S., right, as the suitable candidates. And the way it classifies people is, if you put a women name, it kind of assumes that it's a medicine, and for example, if you do a Google search for a medical term with a lady name on it, it kind of assumes it's a nurse. If you use a male name, it's a doctor. That's sort of a far less intelligent things the intelligent machine do, right? Which is absolute nonsense. Historical processing is no evidence to how an individual's abilities are. We are always self-correcting, right? We have so many women executives and so on. But AI is not capable of understanding that, because it doesn't have maybe a sort of understanding that we possess, right? And partly because maybe its ability, its need to process the historical data and sample data to do that job. Same thing here. A few examples of bias in the U.S. On the left-hand side, you see a white person, has committed more serious offenses in comparison to the black person who's been a juvenile offenses, some misdemeanors, but he's considered more risk than the other one. Just by looking at that person, so the AI trust that white person more than the black person, which is very unfair and very dangerous too. You trust a person and then he turns out to be the evil, where you didn't trust a person, but he's turned out to be a very helpful one. So how do we eliminate this sort of a bias in our algorithms? A very important thing, and it's not going to be an easy answer. It requires ethics, just like we learn. Even when we did not understand Tirukkural, we all used to learn that, and because it was supposed to impart values in us, and we do believe that it has really imparted, even though we may not have understood that time. But it helps us to make right decisions in life, and we need to do something for AI as well. We maybe teaching the people who create AI constantly about values and ethics, making sure that it doesn't do any of this, and thus in the larger interest of the society is a task that we need to somehow solve. So a few points to ponder around there. Like I think I brought this question again and again a few times. Can you imagine if your boss at work is an artificial intelligence machine? Will you like it? Will you work for him? If there's a job opportunity on the classified that says your boss is an AI, would you apply for that job? What jobs would you never want AI to perform? We spoke about doctor speaking to a patient, but what other jobs do you never want to perform? And how do we make AI deliver ethical solutions? One of the very important thing about the social evolution so far has always been about values and virtues. How do we make AI virtuous? So those are questions to think over. in summary, when considering AI application, it's important for society to look at the potential pitfalls. So if you're a startup entrepreneur, if you want to start up a business, the excitement of AI is great, but don't ignore the pitfalls. You have to remember the pitfalls from day one. Otherwise, you may create a machine that you yourself may not sustain with. And another important aspect to consider is the relationship between ethics and law. What is legal is not always ethical. Something what you do could be legal but not ethical, right? So, for example, to create AI to use fake news is not illegal, but it is unethical. So we always get this videos of Barack Obama, making some speeches, but they are not really Barack Obama, but it's a AI, animation. All right. So how do we deal with this sort of situations? Is a question. Well, that brings us to the conclusion to this session. So we went through the introduction. What is AI historically, and we looked at the definitions of AI. We looked at the ecosystem. And what is machine learning, what is deep learning and neural networks, and working with AI, what it means, what are the different types of intelligence. We looked at the research areas. We talked about the SWAM AIs, and we talked about the hardware, advancements, and we also touched on the ethics in artificial intelligence. I think these are the very important topics. If you started thinking these lines, and you have now a overview of AI. Obviously, you can deep dive into it, but this is what industry is, dealing with it at the moment. And there are areas of advancement, but this is essentially what you need to know about AI. That's it. Anybody has any questions? I'm happy to take that now.
Yes, sir. There are some questions. I'll tell you one by one, sir. The first question is, if I am a multi-talent personality, is there any possibility to overcoming all the fields?
Well, multi-talent, see, it doesn't, so those categorization doesn't mean that one person cannot have, two abilities, right? So if you look at, Leonardo da Vinci or someone, probably has done so many different research in many different areas. He's a painter, he's a sculptor, he's a scientist, he's a, an alchemist, he's everything, right? And there will be a lot of examples of that in our thing. Bharadiyar, I amazingly admire that guy, Bharadiyar. He's a freedom fighter, he's a poet, he's such a young age, extraordinarily intelligent, So somebody possessing multi-talent is their ability, Someone can be very good in maths as well as music. But what it only means is that, you have various types of intelligence in one person. They don't aggregate into a superior intelligence. It doesn't mean that if you are very good in maths and you're very good in music, you are somehow more superior than someone who is very good in music or only very good in maths. That's what it implies. But the segregation also leads us to think, which areas could be automated, right? So tackle the problem individually rather than having to, build a machine that is good in everything. You don't need a machine that is good in maths, good in image processing, good in, talking. There's nothing wrong in having that one, but you don't have to.
The second question is, how AI differs from machine language?
So AI is, AI is the overarching name for machine language and deep learning, right? Or anything that is intelligent is artificial intelligence, right? Any intelligent activity a machine would do, and then you go into machine learning. It's a way for making the machines learn. Machine learning is a way of making machines to learn and make a decision. Deep learning is a different way of making machines to learn and take a decision. So if you remember that picture I showed, AI sits at the very outer layer of a circle. Within that circle, you have ML and deep learning.
The third question is, what are all the languages used in developing AI?
I think every organization seems to be creating some libraries. Python is very popular. I think TensorFlow, Google's TensorFlow is the most commonly used, I think, programming technique. And you have Python Torch, I think. We've got R programming, more statistical related ones. I think that Facebook has something. different organizations have some of these algorithms. So if you want to really play around with it, maybe maybe Python Torch. Some of my friends recommend Python Torch for it to being good in presentation, and some recommend TensorFlow because
Can you say some information about implementation of ANN?
Implementation of, sorry, what?
ANN, artificial neural networks.
I'm not sure what the question means. So if the question is about, look, I have got a photo like the Google Lens, for example. You point a Google Pixel phone to a picture, and then it tells you what a particular flower is. That's an application of AI, right, or a deep learning algorithm. So what it does is takes that photo, processes that pixels and maps it against the different design patterns to arrive at a answer that is accurate, right? That is an example of how you do that. And if you want to know about, look, how do I apply a K-class, K-means algorithm, or how K-means, then you may want to do some reading on that particular technique itself, right?
That's it, sir.
All right.
Ma'am?
Yeah. Karthik sir, we had a very wonderful and informative session. Thank you so much, sir.
All right, the pleasure is
Hello.
mine, and thanks a lot for being present.
Reena ma'am, you can conclude, ma'am.
Good evening, one and all present here. On behalf of Ishwari Engineering College IT Department, I take this opportunity to propose this vote of thanks. I thank you all. At the outset, I would like to thank our chief guest and eminent resource person, Mr. C. Karthik Raja. Thank you, sir, for this wonderful session. In spite of your busy schedule, you have accepted our invitation. Thank you, sir. And I would like to thank the management and the respected principal, sir, and our beloved HOD ma'am for our enthusiastic and continuous encouragement and support on us to uplift our leadership qualities. Thank you, ma'am. And once again, I thank all the participants for their responses and their cooperation throughout this session. Once again, I thank you all. Participants, I have provided the feedback link in the chat box. Once you have filled the feedback link, you can leave the session. Thank you all. Thank you, sir.
All right. Thank you very much, everyone.
Sir, we had a wonderful session. Thank you, sir. Participants, you can fill the feedback link which is provided in the chat box.
Yes, ma'am. Thank you.
Thank you, sir.
Thank you all.